problem to get into a more complex problem. All right, so we're supposed to solve for x. We have 2 plus square root of x equals 6. Well, in order to solve this problem, we need to isolate the kind of function, that square root of x, because we know at some point we need to square both sides. It's easier when it's all by itself. So we're going to isolate that square root of x. So I would just subtract 2 from both sides. I don't know what's happening out there. But. So we're going to be left with square root of x equals 4. How do I get rid of a square root? Cool. Well, square everything. So we're going to go ahead and square everything. So I'll square this side, I'll square this side, and that's going to end up with x equals, just one number works in there, 2. Not 2. Hang on. I'm thinking way ahead because we're about to take the square root in a second. It'll be 16. Only 16 works on this problem. The square root of 16 equals 4. Note, the square root of negative 16 does not equal 4. You can't take the square root of a negative number. Because what we're going to do now is I'm going to replace this square root with a square. We're going to do another problem. We're going to do a problem where we're going to go 2 plus x squared equals 6. It's going to be generally the same process. We're going to have x squared equals 4. But the big problem comes in next. What happens when I take the square root of both sides? What do I have to remember to add to it? To add something specific to it. Jacob. We have to add positive or negative. So this is going to result in x equals, basically, so let's do it up here. So we're taking the square root of both sides, which means I have to do positive or negative. So we're going to end up with positive or negative 2. So when I take the square root of both sides, I need to remember it's positive or negative. Because what they're actually asking right here, so when I have x squared equals 4, I'm asking you what number can you plug in for x, that when I square it, it becomes 4. 2 squared equals 4, but negative 2 squared also equals 4. It's really nice that we have this nice situation where if I take the square root, I just add a plus or minus to get both of my answers. So you're allowed to have 2 answers here. That's actually a quasi-problem. We just never really talked about it. And the fact that square root of x plus or minus is not a function. You get 2 answers out. I have 2 possible values for x. If I ever have y equals plus or minus something, say square root of x, that is not a function. Note, if I would graph this, it would look like this. That is not a function, but we're okay with that. I didn't ask, is it a function? My question was, what values can I plug in for x that make this statement true? I'm not restricting it to being a function. I'm just saying, what values work for this? Even though what works for it is a non-function, that's okay. That's my only question, is what values of x work here. That's what we have to keep in the back of our mind when we start working on these next few problems. So up until today, I would tell you sine inverse has to be restricted to quadrants 1 and 4, correct? 1 and 4, I should probably put them over here. 1 and 4 is where I have to restrict sine inverse 2. We're not going to worry about restricting our domain on these problems. I'm going to get to a stage and I'm going to ask you what values can I plug in that give out this answer. And you'll see that in just a second. But don't worry about restricting domain today. In fact, I'm only asking for exact values that exist between 0 and 2 pi. 0 and 2 pi. Remember we did sine inverse, we had to go down to the negative angles? We don't have to worry about that. We're just going 0 to 2 pi, what values work. So let's pretend like this is the same problem we had up above. Now, when I have trig involved, you are going to isolate your trig. So your trig trumps everything else. You're going to isolate your trig. So I'm going to make sure my sine is all by itself on one side, and everything else is on the other side. So the first thing I'm going to do is I'm going to go ahead and add sine x to both sides. So we're going to go ahead and add sine x to both sides. Maybe we'll write that down. So we're going plus sine x. That'll turn that to 0 plus sine x. That's going to give me 2 sine x minus square root of 2 equals 0. Let's go ahead and add square root of 2 to both sides to give me 2 sine x equals square root of 2. I will not square it at this stage. Our goal is to strictly isolate your trig before you do anything else. So I'm not going to square both sides because that's going to make my sign more complicated. We want sine x to be all by itself, just sine x, just tangent x, just cosecant x. Whatever we have, we want it by itself. That's why we're not going to square both sides right here. Instead, we're going to divide both sides by 2 to give me sine x equals square root of 2 over 2. That should seem familiar. That's something that was on our unit circle. However, at this stage, I am not going to take the sine inverse of both sides because that's where we confuse ourselves a little bit more. Instead, I'm going to leave it at sine of x equals square root of 2 over 2. Now, I'm going to ask myself, on my unit circle, what angles can I plug in here that are between 0 and 2 pi that when I plug them in, I'll get out a positive square root of 2 over 2? Theo.
Pi 4 and 3 pi over 4.
Say that one more time.
Pi over 4 and 3 pi over 4.
Yep, pi over 4 and 3 pi over 4. If you don't agree with Theo, make sure you check your unit circle. You can have your unit circle out. I'm not testing you on your unit circle knowledge right now. I'm testing you how you can read your unit circle. If you look at pi over 4, the sine of pi over 4 equals positive square root of 2 over 2. The sine of 3 pi over 4 also equals a positive square root of 2 over 2 because sine is positive in quadrants 1 and 2. Note, I did not take the sine inverse of both sides because that confuses people. It tells you to restrict it to a domain. Instead, we're going to ask ourselves, what values can I plug in here that get out square root of 2 over 2? And there's 2 possible values. That is pi over 4, and that is 3 pi over 4. I do want to point out, this restriction of 0 to 2 pi saves you. If it does not have that restriction, that means any coterminal angle to pi over 4 would also work. So you have to do something like pi over 4 plus 2 pi times k. We're not going to worry about that today. All we're going to worry about are 0 to 2 pi. Those are my 2 angles. If you understand that, you understand the crux of what we're doing today. That's all of it. Can you understand isolating a trig and then finding on the unit circle what makes that true? That's all we're doing today. Our next example is we're given 3 tangent squared x minus 1 equals 0. Find the exact solution in the interval 0 to 2 pi. Our goal is to isolate the trig function. So the first thing we're going to do is we're going to add 1 to both sides. So we'll have 3 tangent squared x equals a positive 1. Then I'll divide both sides by 3 to give me tangent squared x equals 1 over 3. Then when I take the square root, we have to remember what we did in the bell work. You have to have plus or minus. So we're going to have tangent of x equals plus or minus the square root of 1 over 3. We can simplify that. Square root of 1 is 1. So we're going to have plus or minus 1 over the square root of 3. Multiply the top and bottom by square root of 3, and we're going to end up with plus or minus square root of 3 over 3. Well, that's good because that's something on our unit circle. So we're boiling down to tangent x equals positive or negative square root of 3 over 3. Remember, we aren't taking tan inverse because that tells us we're restricting it to a domain. You can if as long as you keep it straight, but I find most people find it easier just to stop here and just ask yourself. All right, positive or negative. That means tangent can be in any quadrant. So we're probably going to have 4 answers here. So we're going to have x equals, can someone tell me the first angle that when I plug it in for tangent, I get out square root of 3 over 3? What is the very first angle we got? Pi over 6. Now, this is what's nice about using radians here, pi over 6. I know in quadrant 2 there's one that's either positive or negative of square root of 3. How do I put pi over 6 into quadrant 2? So I know it's the same location, same value. How do I put it in quadrant 2? Labib. No, not quadrant. I'm sorry. I'm asking in a weird way. Like I want, so pi over 6 in quadrant 2, the reference angle would be pi over 6, but I'm in quadrant 2.
Oh, 5 over 6.
Say that one more time.
5 over 6.
5 over 6. Yeah. So 5 pi over 6. What would it be if I'm in quadrant 3? Well, 7 pi over 6. And the final one was what happens if I'm in quadrant 4? 11 pi over 6. Thanks, Labib. Those are all the 4 possibilities that work for this one. Questions on that? So the big thing is here, I give you an equation, and I want you to find the exact solutions in interval 0 to 2 pi. Note that 2 pi is not included, so we'll never give an answer of 2 pi. What can I plug in for this that will work? And all 4 of these would work. All right, our next one is a factoring problem. So if I have sine squared x equals 2 sine x, we're going to move all our signs to one side. So that's going to give me sine squared x, not equals, but minus 2 sine x. That's going to equal 0. Well, right now I'm at the stage that's basically like if I had x squared minus 2x, x squared minus 2x, we could factor out an x. Well, the same thing is with sine x. If I have sine squared x and a sine x, I can pull a sine x out of both of those. In other words, I can divide a sine x out of both of those. So I'm going to factor a sine x out front. So we're going to have sine of x equals sine of x minus 2 equals 0. Now I have what's called the zero product property. The zero product property says if you have something times something equaling 0, either this something equals 0, or this something equals 0, or they both equal 0. So I have to come up with what values will make this part 0 and what values will make this part 0. So I usually just kind of branch them out. I say, okay, either sine of x equals 0, or sine of x minus 2 equals 0. And now we're looking for x values that make this true, and we're looking for x values that make this true. So the first one is sine x equals 0. What angle, sine of angle equals 0, what angle is that? Or what angle are they? There might be more than one. Yeah. 0 and 180. I'm going to go ahead and I'm going to use pi instead of 180, just because they said the interval from 0 to 2 pi, so I'm going to leave it in radians. 0 and pi. Sine of 0 is 0. Sine of pi is also 0. They're straight across from each other, so yes. Our next one, I'd simplify it just a little bit. I would have sine of x equals 2. What angle, when I plug in there, so sine of what angle gives you out 2? Sine of what equals 2? There isn't one. Picture your sine graph. Your sine graph bounces between 1 and negative 1. The biggest the value can be is 1. The smallest it can be is negative 1. In fact, if you draw a unit circle is on the xy plane, The highest point we can get is this point up here. That is the point 0, 1. To get to 2, I would have to be way off my unit circle. Well, that doesn't make any sense. I can't make a new unit circle. It's all the values that are on there or nothing. This does not exist. This is a does not exist. Sine can only equal 1 to negative 1. 1 is the biggest value, negative 1 is the smallest value you can reach. So if I ask for the sine x of negative 3, you say that doesn't exist either. There's no angle I can plug in that will come out with a negative 3 or a 2. It's got to be between 1 and negative 1. All right, our last problem. Find all solutions of 2 sine squared x minus sine x minus 1 equals 0. Remember, on problems like this, you can picture it if it's just being 2x squared minus x minus 1 if you want to. We're just factoring it. We can use factor by grouping, we can use the snowflake method, or we can kind of use the guess and check method. The guess and check method is just going, okay, I know it's sine squared x. It'd be sine x out front here, and then we'll have a sine x here. Because 2 sine x times sine x gives me 2 sine squared x. Now I'm looking for a number that when multiplied together gives me a negative 1. But when I multiply this 2 times the last term and 1 times this term would give me a negative 1 also. What numbers fill in those spots? What numbers satisfy both of those situations? So once again, I'm looking for a number, 2 numbers, that when you multiply them together, they give you negative 1. When you multiply it by this one, you multiply by that one, you add them, you get out a negative 1 as well. What 2 numbers fit in there? Theo. Positive 1 and negative 1, in that order. 1 times negative 1 gives you negative 1. Negative 1 times 2 is negative 1. 1 times 1 is 1. Negative 2 plus 1 gives me that negative 1. So that is our factored version. We have 2 possibilities. Either 2 sine x plus 1 equals 0, or sine x minus 1 equals 0. Well, let's solve the first one, the left one. I would need to subtract 1, divide by 2, so I'm asking when is sine equal to a negative 1/2? So where is sine equal to a negative 1/2? Well, sine is negative in quadrants 3 and 4. So let's start this out a different way. Let's pretend I don't have my unit circle. I have no unit circle on me. Where does sine equal a positive 1/2? Where does sine equal a positive 1/2? At pi over 6. Well, pi over 6 will give me a positive 1/2. I need to be in quadrants 3 and 4. So if I know pi over 6 gives me 1/2, and I need to put that in quadrants 3, we'll just make it 1 bigger. So instead of pi over 6, we'll make it 7 pi over 6. That will put it in the 3rd quadrant. To put it in the 4th quadrant, we just multiply by 2, subtract 1, and I have 11 pi over 6. That is kind of using the reverse of your reference angle to say, well, I know where sine equals a positive 1/2, that's pi over 6. Let's put pi over 6 in the 3rd and 4th quadrant, and we have our 2 answers. Sine of x minus 1 equals 0 would be sine of x equals 1. Where does sine of x equals 1? And then we are done. Yeah.
Pi over 2.
It'd be at pi over 2. So x just equals pi over 2. So we have 3 possible values that work for this one. We have 7 pi over 6, 11 pi over 6, or x equals pi over 2. I guarantee if you plug that stuff in, this will come out as a true statement. Any questions on anything we covered today? So I think the easiest way to do this lesson is almost forget about what inverses are, like the sine inverses and restricting them to quadrants. Just think about at this stage, sine of x equals negative 1/2. What angles give you negative 1/2 when you plug in for this? All right, that's all I have for you.